On the night of August 7th, 2026, the sky over eastern Sicily filled with an unmistakable orange glow. Mount Etna, Europe's tallest and most active volcano, had entered a fresh phase of powerful eruptive activity. The Toulouse Volcanic Ash Advisory Center registered a sharp jump in output and immediately classified the surrounding airspace at the highest possible aviation warning level, coded red. Observers tracking the plume estimated that ash and volcanic gas had climbed to roughly 7 kilometers above sea level, a figure specialists place among the more forceful outbursts the mountain has produced in recent years. The event caught many off guard. Just days earlier, Etna's activity had looked comparatively modest. Then, around 11 at night local time on August 6th, seismic instruments run by Italy's National Geophysics and Volcanology Institute picked up a sudden spike in volcanic tremor, and within hours the mountain shifted into an intense phase of material discharge. What set this particular episode apart was that molten rock broke the surface in 2 separate places at once. At the summit, a sustained lava flow and towering fountains of incandescent rock poured from the Veragine crater, sitting at roughly 3,000 meters, the same vent that had dominated the mountain's activity for the previous month. At almost the same time, on Etna's eastern flank, a brand new fissure tore open inside the Valle del Bove at an elevation of around 2,750 meters. The Valle del Bove is a colossal horseshoe-shaped depression carved into the volcano's eastern side by repeated ancient flank collapses. It covers more than 37 square kilometers, and in places, its walls rise a full kilometer above the valley floor. This is where lava most often ends up when the summit craters are overloaded with magma, since the terrain naturally channels molten rock downward and away from the populated western and southern slopes. 2 simultaneous eruptive points are unusual even for a volcano as restless as Etna, and scientists read it as a sign that the magmatic system beneath the mountain was, for a period, charged with material under considerable pressure, temporarily widening the pathways it uses to reach the surface. The ash that reached 7 kilometers into the sky is not smoke, and it is not the residue of anything burning. It is a fine suspension of shattered volcanic rock and glass, formed the instant fountaining magma meets the open air and cools almost instantly. Individual grains range from a fraction of a millimeter down to a few dozen microns across, small enough to stay aloft for hours or even days, drifting with prevailing winds for tens or hundreds of kilometers from their source. That property is precisely what caused the disruption to air travel across southern Italy. Catania Fontanarossa International Airport, sitting only 45 kilometers from the summit, was forced to suspend all arrivals and departures outright, as controllers closed the airspace sector designated C1 until ash concentrations dropped to a level considered safe. Dozens of flights operated by major European carriers were either canceled outright or diverted to Palermo, Comiso, and Malta's Lucca airport. Passengers were urged to check flight status well in advance and to prepare for delays that could stretch into many hours, and several northbound European routes were rerouted at the planning stage to avoid the drifting cloud altogether. The reason aviation authorities treat volcanic ash with such uncompromising caution lies in the basic engineering of a jet engine. Inside a working turbofan on a commercial airliner, core temperatures routinely exceed 1,400 degrees Celsius. Hard silicate particles pulled into that heat along with the intake air, do not burn away. They melt, turning into something close to liquid glass. That molten film coats the turbine blades, disrupts the carefully engineered airflow, and gradually clogs narrow cooling passages and fuel nozzles. As the aircraft later descends into cooler air, the glassy coating can re-solidify, and the result can be a sudden loss of thrust, or, in the worst cases, a complete engine flameout mid-flight. Beyond the engines themselves, abrasive ash particles can sandblast a cockpit windshield to opacity and damage airspeed sensors within minutes, instruments a crew depends on for safe control of the aircraft. That is why modern civil aviation rules call for avoiding any visible ash cloud by a wide margin, regardless of distance from the source volcano. The risk is judged too severe to rely on a visual estimate of how dense a given cloud might be, and restoring an engine damaged this way can cost an airline millions of euros. The disruption was not confined to the sky. Strong, gusting winds carried the ash plume directly toward communities at the volcano's base, including Zafferana Etnea, Milo, Linguaglossa, and several other towns along the eastern flank. Residents described a thick gray film settling over cars, rooftops, and garden trees. Local authorities advised people to limit time outdoors, to wear protective masks where possible, and to avoid motorcycles and bicycles altogether, since a layer of ash on asphalt sharply reduces tire grip in a way that closely mimics black ice. Doctors issued a separate warning aimed at anyone with chronic respiratory conditions, such as asthma, bronchitis, or emphysema, cautioning against inhaling the fine dust, since the sharp, glass-like edges of individual ash particles can irritate lung tissue. Several municipalities temporarily closed schools and playgrounds, and municipal crews began washing down streets with water trucks to stop the settled ash from being kicked back into the air by passing traffic. Specialists at Etna's Volcanological Observatory point out that this kind of behavior fits comfortably within the mountain's long-term pattern, even though the intensity of this particular episode exceeded what had been recorded in the preceding weeks. Seismic data suggests magma rising from a depth of roughly 3 to 4 kilometers is moving through a network of fractures and conduits that has been forming inside the volcanic edifice for decades. Infrasound sensors, which register the low-frequency rumble produced by gas and molten rock moving beneath the surface, had already picked up a steady tremor several hours before the eruption became visible, one of the few reliable early indicators scientists have, even though the exact timing and force of any single outburst remain genuinely difficult to forecast with today's instruments. Alongside the seismic and infrasound networks, remote sensing satellites track heat anomalies on the volcano's flanks, well before any flame becomes visible, while a ground-based network of satellite positioning receivers records even minor surface deformation caused by magma accumulating in reservoirs underground. Etna does not erupt from a single fixed opening. Its summit carries 4 separate craters: Boca Nuova, the northeast crater, the southeast crater, and Varajan, each capable of activating independently of the others, and occasionally, as happened here, at the same time. Beyond the summit, the mountain's flanks are dotted with hundreds of secondary cones and fissures left behind by past eruptions. Some are thousands of years old, others formed within the last few decades. The mountain's height itself is not fixed. shifting by a few meters after any major episode that either collapses a crater rim or builds up the cone further. The latest measurements put Etna's elevation at roughly 3,357 meters, making it not only Europe's most active volcano, but also one of the tallest anywhere on the continent. In recent years, the mountain has produced comparably forceful pauses of activity more than once, with strong lava fountaining recorded in February of 2025 and at various points in earlier seasons, though the precise duration and strength of any new episode depend entirely on the current state of the magmatic system and cannot yet be predicted with full certainty by any available method. Despite the recurring eruptions, Etna is less a source of dread for the people of eastern Sicily than a familiar part of the landscape, and in many ways, the foundation of the local economy. Volcanic ash, rich in potassium, phosphorus, and magnesium, has spent millennia building some of the most fertile soil in the Mediterranean. It is on these same slopes that farmers grow the region's celebrated Tarraco oranges, Bronte pistachios, and grapes destined for locally protected wines. Terraced farming on hardened lava fields is its own local tradition, with generations of farmers adapting to uneven rocky ground by stacking cooled lava into low retaining walls around vineyards and orchards. The mountain's slopes also welcome hundreds of thousands of tourists every year, many riding cable cars or joining licensed guides in four-wheel drive vehicles for excursions toward the craters. And volcano tourism remains one of Sicilian tourism's central draws, alongside the island's ancient monuments. By the morning of August 8th, Italy's Civil Protection Agency reported that ash output had eased somewhat from the previous night's peak, though explosive activity continued at the Voragine crater, and lava was still flowing within the Valle del Bove. Catania's airport resumed a partial schedule as wind pushed the Plume out toward the sea, though air traffic control warned that any shift in wind direction could bring restrictions back with little notice. The civil protection alert level for Catania province remained elevated, and volcanologists kept round-the-clock watch on seismic and infrasound readings to determine whether the mountain was settling or simply pausing before another surge. Forecasters separately noted that wind direction over the following day would prove decisive. Air moving out toward the Ionian Sea would ease pressure on ground infrastructure, while a shift back toward land could once again complicate operations, not just at Catania, but at neighboring Sicilian airports as well. The way European aviation authorities responded to this eruption reflects how much the handling of volcanic hazards has changed over the past 2 decades. In the early 2000s, ash clouds were often assessed only roughly, and decisions to close airspace could lag well behind the actual danger. Today, data streaming from weather satellites, ground observers, and atmospheric dispersion models updates in something close to real time, letting control centers plot a cloud's likely path many hours ahead and adjust dozens of flight routes simultaneously. That forecasting capability is what let airlines redirect aircraft before the Plume had actually reached the air corridors over the Ionian Sea, cutting both passenger risk and the financial cost of last-minute cancellations. Alongside the aviation authorities, seismologists across Italy have also been watching events unfold, since heightened Etna activity typically draws attention from researchers studying the broader relationship between volcanic and tectonic processes across the Mediterranean. Sicily itself sits at the junction of the African and Eurasian tectonic plates, and that complex geological setting is precisely why the island hosts active volcanism alongside elevated seismic activity in the same region. Current science does not support any direct causal link between local Etna eruptions and earthquakes elsewhere on the island. But monitoring is handled holistically all the same, with data from volcanic stations regularly cross-checked against readings from the regional seismic network to catch any departure from the normal pattern early. Observation of Etna stretches back nearly 3,000 years, making it one of the most thoroughly documented volcanoes on the planet, with eruptions described in ancient sources, including accounts by Greek and Roman writers who wrote of rivers of fire reaching the sea. Across that span, the mountain has repeatedly shown it can destroy, wiping out farmland, cutting roads with lava, and grounding air traffic, just as easily as it can create, renewing soil and shaping a landscape now recognized as a UNESCO World Heritage Site for representing an ongoing geological process. Despite its force and its visible impact on Mediterranean air travel, specialists are, for now, treating the current episode as consistent with Etna's typical rhythm, in which stretches of relative quiet give way to short, intense bursts of activity before the mountain settles again. Even so, each event like this is a reminder of how tightly modern infrastructure, from transatlantic flight schedules to daily life in small Sicilian towns, remains bound to processes unfolding deep beneath the surface, entirely indifferent to human plans and timetables. Scientists stress that as long as seismic activity shows no sign of tapering off and infrasound levels stay elevated, it is too early to call the current phase finished, and residents and visitors alike are advised to follow official civil protection updates and to avoid entering restricted zones on the volcano's slopes on their own. For the local tour operators who guide groups up to viewing platforms around 2,000 meters most days of the year, an eruption like this one means temporary rerouting. Some trails close, and guides redirect visitors to safe vantage points from which the lava fountains and ash column remain clearly visible regardless. Footage that often goes on to become some of the island's most recognizable imagery in international news coverage. For Etna itself, this episode is simply another entry in a centuries-long record. A mountain that, as local volcanologists like to put it, never really sleeps, only shifts from one quiet phase to the next, all the while remaining one of the most closely studied volcanoes on Earth.